Hey everybody, welcome to week 2 probability. Some extra questions. Now, on top of the homework, I really recommend that you review this video because probability is kind of hard, and these questions can be quite different with those basic principles that we learned. So yeah, this will be on my YouTube channel. At the time when I make this video's not uploaded, so don't know where it's at, but it'll be in that playlist for stats. So here we go, some true or false for you. An event is a collection of sample space outcomes. True, totally true. Let me get my pen back. There we go, that's definitely true. Two events are independent if the probability of one event is influenced by whether the other event occurs. Nuh-uh, that would be dependent, so this is false. The probability of an event is the sum of the probabilities of the sample space outcomes that correspond to that event. True! It's just that easy. You just gotta memorize it. Fill in the blank. I love how I'm surprised I made this question. If two events are independent, we can blank their probabilities to determine the intersection probability. Well, the answer is multiply. Come on, let's multiply. All right, here we go. The fun stuff. So, find the probability that two people chosen at random are born on the same day of the week. Well, so you kind of got, dang, where did my pen go? Come on. Okay, so you got person 1. And then, because these are independent events, we know we're going to be multiplying some probabilities together, so I put a multiplication sign, and here's person 2. So I kind of draw a space to kind of signify, well, this is where I'm going to put in the probability for person 1. So there's 7 days in a week, and guess what? There's a 1 out of 7 chance that you're going to be born on one of those days, so there's the first probability. Now remember, this is multiplication here. Now person 2, well, how many ways can they be born on the same day as this person? Well, there's only 1. Right? So there's a 1 out of 7 chance that this person is going to be born on a Monday times the 1 way that this person can also be born on Monday. So kind of weird, but it's kind of like a 100% chance. So your answer is 1 out of 7. Now you'll notice that upside down here in the corner, I've cleverly put the answer in upside down. So there you go. Now, totally love this question, made it up. I got a little weird typo in here. A circus vendor is designing a game of chance for their carnival. Maybe that's what they're doing. Sounds cooler, but should just say it's designing a game of chance. There. In the game, 2 bags contain marbles of different colors. Red, blue, and green. First a marble is drawn from bag 1, and then a marble is drawn from bag 2. Ooh, I like it. Bag 1 contains 5 marbles. There they are. So I suppose, N for this bag is how many? There's 5. And bag number 2 has 7 marbles, so N is 7. Great. What do we got? Find the probability of getting a red marble from each bag. So I like to put my little spaces here and go red, red. This will be bag 1 and this will be bag 2. Now, because these events are going to be independent, they're 2 separate bags, right? So what happens in bag 1 doesn't affect bag 2. I'm going to be multiplying these probabilities together. Now notice how I always try to think of that ahead of time. When I'm doing my probabilities, am I adding or multiplying? Those are usually your 2 options. Now, for a red marble in bag 1, well, there's 2 red out of, the 5 times. In bag 2, we just got 1 red, 1 out of the 7. So independent events, we multiply, and we go 2 times 1, 2, 5 times 7, 35, and you got your answer. Now you can convert it to a decimal and check my upside down answer, but that's a perfectly acceptable way to leave the answer. Find the probability of getting a blue marble from bag 1 and a green marble from bag 2. Well, that's great. So same kind of setup. Draw a line, and we're going to go blue from bag 1 times green from bag 2. And now let's see. For bag 1, we just got 1 blue out of the 5, and then multiplied by 2 green out of the 7. So 1 times 2 is 2, and then 5 times 7 is 35, and you can go check that wonderful answer down there. Now, it's all good. I'm just checking my answers here. Yeah. Yeah, that's good. Okay. So, there you have it. Same question, different sub-questions, I suppose. Find the probability of getting the same colored marble from each bag. Oh, yikes. Well, that one's going to require some thought here. How many ways, right? How many ways? How many ways can I do that would be my first question to me, right? So you kind of think of the sample space so that you can come up with the probabilities. Well, there's only 3 different colors, right? So, I mean, we can get red, red, blue, blue, or green, green. Yeah. So if I can figure out the probability of red, red, and blue, blue, and green, green, I could have my answer here. Now the question is, what's the math operation that's happening between them? So these are separate events, so we're going to be adding them. Remember, the word or means addition. So I can get red, red, or I can get blue, blue, or I can get green, green. So it's kind of the key. Got to add up those separate probabilities. So for red, red, there's, 2 out of 5 for bag 1 times 1 out of 7 for bag 2. Okay, now notice how here I'm multiplying, right? Because this is the experiment. But then I'm going to add the next case, which is 1 out of 5 for the blue. And then, 4 out of 7 for the blue there. Now for green, we got 2 out of 5 times 2 out of 7. Well, there you have it. So I suppose underneath I'll do my work. So 2 times 1 is 2. 5 times 7 is going to be 35. Plus, here I get 4 over 35. Plus another 4 out of 35. You can add up these probabilities. Got the same denominator, so you can just add the numerators. And you get 10 out of 35. Wonderbar. And you can leave your answer like that. If you want, you can reduce it. You can divide by 5 and get whatever, 2 out of, 7? Did I do that right? It's been a while. You can check the answer down here, the decimal. Still good. Let's see. D. I love D. Because this question, find the probability of getting different colored marbles from each bag. It's quite difficult. If you're trying to figure out the sample space, you realize that it can get quite complicated pretty fast because, you got the 3 different colors on the first round, right? And then if you get red here, well, in the second round, you only got blue or green, so on and so forth. So you can figure it out and do all those probabilities, which is a lot of, it's doable. It's not impossible. But that's a lot of time that you probably don't want to spend on the test. So is there another way to do this? Well, yeah, you can use the good old complement rule. Complement rule. You can expect the complement rule to come up somewhere. It's such an important concept in probability. Let's see here. So we know that all the probabilities have to add up to 1 or 100%. If I want all the different colored marbles, I need to remove all the cases where the marbles are, think about it, pause the video, think about it, the same color, right? The only time they're not different colors is if they are the same color. I see what I did there. So I kind of stacked these questions and purposely did it this way so that you can realize, oh, well, in part C, I found out the same colored ones, and in part D, they're asking me for the different colored ones. So if I go 1, subtract all the cases where it's just the same colored, I'll be left with all the cases where they're not the same. So in this case, I'm going to be left with 25 out of 35, and you can convert it to a decimal and check your answer down there. Remember, 1 is the same thing as 35 out of 35. So if you're wondering what happened with the math there, that's what happened. That's a sneaky one. That question could be a lot harder if I gave you this setup and then just gave you part D, just as a standalone question, right? That'd be a lot harder because you're not sort of being carefully guided there. Who knows what I'm going to do? Crazy guy, could do anything. Moving along. Ooh, yes, in a large organization, 55% of all employees are female, okay? 25 have a business degree, and 40% of all males have a business degree. Okay, what is the probability that one randomly selected employee will either be a female or, so remember or means add, have a business degree? Okay, so they're asking me for probability of female or, so plus, probability of having a business degree. Now, this question could be quite hard, maybe without a table. Of course, you could use the formula from our formula sheet and figure it out maybe, but I think when I look at this one, I'm like, I really just want to make a table. It doesn't look like there's a lot of info here, but we basically have female and male and business and no business, right? So there's going to be 4 different categories there, right? So what I do is and I'll do my best here. I have this pen, but I can't actually see where I'm writing until it's on the screen. So we got our females. And we'll draw a reasonably straight line here. We'll draw another one. And another one. And I think I need another one. There. Then we got our males. And draw a line like this. And another one like that. Not bad at all. Round of applause for the professor. So here we'll have business, and then here we'll have not business as in no business degree, and then we'll kind of have our totals over here. Totals, and yes, and some totals down here. Now let's see if we can't make sense of this. Now when they're talking in percentages, you can just imagine like they're giving you these numbers out of 100. Okay, so when I see in a large organization 55% of all employees are female, that means that they're giving me this column total. So 55 out of the 100, right? 55%, so it's got to be out of 100, are female. Well, that's cool, because now I know that there's 45 males in total. See how that works? And 25% of the employees have a business degree. Now, it doesn't say 25% of the females, it just says 25% of the employees. So that's like everybody, right? Have a business degree. So where does that go? It's not here under business and female. It's not here under male and business. It's here. 25%. Okay. Nice. Does that help me get anywhere just yet? Why? Yes, it does. Because I know that these totals have to add up to 100, so if 25% of the employees, so 25 out of the 100, that must mean that this is 75. So this number was calculated, and this number was calculated. So I'm just circling the numbers that we calculated outside of the question just for fun. Now, 40% of all males have a business degree. Here you're going to have to do a bit of work, because they're saying 40% of all the males have a business degree. So here's males and business. We can't write 40 here, because that would mean that would mean 40, and the total is 25. So we can't write 40 here. So we got to go 25 times 40%, so 0.4. Now that's going to give us how many actual males there are that have a business degree. So when you type that in on your calculator, you'll get 18. So now I know that this is 18. Now this was kind of given in the question, right? They give it to us as a percentage, but that's really the tricky part here, is realizing this is 18 and not 40. Okay, so now I can work backwards. I know there's 25 in total. 18 of the males have a business degree, so there's got to be 7 females here. So I'll circle that. And now we can just use our column. So 55 subtract the 7 is going to give me this number here. Now I got 48. I guess I'll circle it because I calculated it. I don't know why I'm doing that, by the way. There's no reason. 45 minus the 18 is going to give me male and not business. So that is 27. Great. So I think it's important to do that, because now I can very easily go find, well, what's the probability of female plus probability of business? And I'll even switch colors for this. So take a look here. How many females are there? Well, that's easy, That's this and this. So total 55. So 55 out of 100 is female. Okay, now what about probability of business? Well, probability of business, that's not stipulating male or female. It's both, right? So how many people have business? Well, they have business, but we've already included that 7, right? That 7 is included in the females. We don't want to include them twice. So we want to make sure that we just include that 18 out of the 100. So there you have it. You add those up, and you're going to get 73 out of 100, or the answer of 0.73. That's one way of doing it. There are other ways. Like I said, you could use the formula from the formula sheet, where you realize that if you're going to add these two up, you can do that. You just got to make sure that you delete the intersection of female and business, right? So that you don't include it twice. Yeah, there's my advice for that question. Okay. Next question. A group has 12 men and 4 women. If 3 people are selected at random, what's the probability they're all men? Okay, well, how many people in total? 12 plus 4, 16. Now we want all men. So I like to write my line. M for men, M for men, M for men. Together it goes, So, first time you're picking a person. How many are men? 12. Out of how many? 16. Now, times, what's the next one? How many men? Well, we've chosen one already, so there'd be 11 left out of only 15 people, times 10 men left out of 14 people. Now we multiply them all together, and you'll get whatever answer it is that I have down here. Great. Next. Oh, the container question. Yes. So, container 1 has 8 items. So, I don't know how you want to write this out. Let's see. 2 are defective. 1 item... Oh, and container 2... Oh, I read that wrong. So, container 1 has 8 items, 3 of which are defective. Container 2 has 5 items, 2 of which are defective. 1 item is selected at random from each container. What's the probability that exactly 1 of the 2 items is defective? Exactly 1. So how many ways can this happen? Well, I can get defective, not defective, or, so add, not defective, defective. That's the only way to get exactly 1 defective. So keep in mind this will be container 1, container 2, and container 1, container 2. So what do we do? Well, let's go ahead and go defective and not defective. So container 1, defective items, 3 out of the 8. So 3 out of 8 chances times, now I want not defective from container 2. So container 2 has 2 items that are defective. Now there's 5 in total, 2 are defective, so that means 3 are not defective, right? We're doing not defective. So there's that. We're going to add to it the chances of not defective and defective. So back to container 1, new experiment. There are 8 items. Now 3 are defective, meaning 5 are not defective. There we go. Times, in container number 2, we want defective. So 2 out of the 5. Boom. There we go. 3 times 3 is 9. 8 times 5 is 40. Plus 5 times 2 is 10. Over 40, add them up, and you get 19 out of 40, which will give you the decimal answer that you see down in the corner. All right. What the heck just happened? There we go. Well, Joe. You're pursuing an MBA. All right. He applied to 2 different universities. The acceptance rate for applicants with similar qualifications is 25% for University A and 40% for University B. Wow, very posh. What is the probability that Joe will be accepted at both? You may assume the universities make their decisions independently of one another. Oh, I should hope so. So remember, independently is just basically saying that whatever happens at University A doesn't affect University B. So you're going to be multiplying the probabilities. There's only really one way we can do this. So we want to get accepted at University A, and they have a 25% acceptance rate. So remember, if you're doing a calculation, percentages need to be written as decimals or fractions. So 0.25% chance of being affected there, times a 0.4% chance of being accepted there. Multiply those two together, And you will certainly get the answer 0.1, and you are done and happy. All right, it's not looking good for Joe. So this one here, past company records indicate that 85% of new hires successfully complete their probation period. Suppose 3 newly hired individuals are randomly selected. Okay, the plot thickens. If new hires successfully complete their probation period independently of each other, what's the probability that all will complete the probation period? Huh. Well, this one's actually fairly straightforward. Like, could be hard when you're new, but this is a fairly straightforward question as far as probabilities go. There's an 85% chance they complete their probation period. We want to know that, and it's independent of one another. Okay, so it means we can multiply probabilities. All 3 of them completing their probation period, so you got person 1, person 2, person 3, and we're multiplying the probabilities. What is the probability? Well, there's an 85% chance they complete their probation period. So we're going to go 0.85 for the first guy times 0.85 for the next person, could be a girl, times 0.85 for the next person. Okay, multiply it together, you basically have 0.85 raised to the power of 3. When you type it in on your calculator, you'll get that answer down at the bottom. So next! Ooh, now I like this one. What's the probability of getting 4 tails in a row on a fair coin toss? So I've almost gone to easier, quicker questions for the end. I just thought it's important to have a couple extra questions like this because they're easy, but you need practice for them to get that way. So in a coin toss, you got a 1 out of 2 chance of getting a tail, and all the coin tosses are going to be independent of one another, right? So what happens in one toss doesn't affect what happens in the next toss. So 4 tails in a row would be getting, tails, 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 tails. So 1/2 chance times 1/2 chance times 1/2 chance times 1/2 chance. Speed it up and loop it. You got a little song. So you're starting to notice something here. It is 1/2 raised to the power of 4. There's 1, 2, 3, 4, 1/2. So 1/2 times a half times a half times a half times a half. Whatever, 4 times. You're going to get 1 out of 16, which is the answer. I didn't bother writing it as a decimal. Yeah, type it in your calculator if you like. Now this question is fun. There's a lot of ways to do it. So you're rolling 2 dice. And 6 sides. That's very important. Very important they have 6 sides. What's the probability that the sum, so that means adding the 2 numbers that you get on the dice, of the numbers is 8 or higher? So the sum has to be greater than or equal to 8. Well, this is one of those questions where you probably need to find the sample space. Now, there's no fancy way of doing this one, at least that I know of, because you got to add up the numbers, right? You got to figure out what are all the possible sums of all the numbers, and then check to see how many of them are 8 or higher. This is a great computer question. It's a great question for a computer to solve if it was more complicated, right? Like imagine you had a bazillion sides to the dice. So what I recommend you do is make yourself a table. Now, I've never tried ink to shape. I'm nervous to try it, so I'm not gonna. But make yourself a nice table. Now, if I was really smart, I would have pre-made this table. But I didn't. YOLO! Okay, I'm going to try the ink to text. No, ink to shape. Is it going to know I'm trying to get a line? You know what? It's not doing anything, but it's given me some false confidence, and I'm getting some better lines than usual. Or I'm just getting better at this. Let's see. So we're going to go 1, 2, 3, 4, 5, 6. Oh, man. 1, 2, 3, 4, 5. That'll do. Let me go 1, 2, 3, 4, 5, 6. Now, the clever ones of you, which is basically all of you, you're going to know, this is dice 1, or die 1. I don't even know what's the singular of dice. Is it die? Leave a comment. And then this is the second die. So you got die 1, die 2, and what are we going to do? Well, if I get a 1 and a 1, I get a 2. If I get a 2 on this dice and a 1 on this dice, I get a 3. So I'm just doing the sum. Now you're going to start noticing patterns that if you go down, these just go up by 1, right? Now if I start with a 2 and then I have a 1 on the other dice, I get a 3. 2 plus 2 is 4. 2 plus 3 is 5. Are you seeing the pattern? It just goes up by 1 every time. So this one starts on 3, add 1, goes to 4. 3 plus 2, 5. So this is actually, once you get the pattern, super easy to fill out. And check it out, there's a pattern this way as well. 2, 3, 4, 5, and you can check it. 6, 7. So have we gotten to a sum of 8 yet? Not in this row, but check it out very soon. 2 plus 4, 6, 7, and 8. So we're going to want to do that. Now I'm just going to fill out the whole table, so if you want to fast forward or whatever, go for it. Whew, that was hard. Now I'm going to use my special, a rainbow pen. I am loving this. This is, well, that's awesome. That's great. So, how many possible outcomes are there? Well, 6 times 6 is 36, or you can count it up. There's six rows and 6 columns. So there's 36 possible things that can happen. Now, how many of them had a sum of 8 or higher? Well, circle them up. 8 or higher. Man, we need rainbow pens in real life, because this is awesome. Be even cooler if I made it thicker. So, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I love counting in monotone voice. There's 15 out of 36 chance that the sum is 8 or higher. That's a pretty neat question. Thought I'd show it to you. Lots of ways that I can modify it, right? I could change sum to anything. Subtraction to the, so the difference. Could be multiplication. Neato. Don't know. Yes, that's the end. So, thank you very much for joining me on this extra little journey. I really recommend that you do this video. Of course, if you've watched to the end, then you've done it. Try these questions out on your own later on without looking, and I'll see you next time. Bye-bye.